Okay, let's start the senior high school maths session now. Okay, first question, intermediate. So consider the geometry series. This is the geometry series. So find the value of the p for which the geometry series has a limited sum. Okay, geometry series has a limited sum only when the common ratio less than 1 and larger than minus 1. This time, the common ratio is equal to theta 5 minus theta square root p. To have this geometry limited sum, so this r must be less than 1 and larger than minus 1. Okay, so means theta 5, theta common ratio has to be less than 1 and larger than minus 1. Okay, so if the theta 5, the minus is square root theta p, larger than minus 1, then this means the square root theta p will be less than 6. So theta p will be less than 36. If the theta 5, the minus theta root p less than 1, and this one will have square root p larger than 4. Then theta p will be larger than theta 16, both sides squared. So now for the theta, the geometry series has a limited sum. So theta p must be between theta 16 and then less than 36. Okay, the second one. Find the limiting sum of the series given the theta p is 20. P is 20 is between 16 and 36. The p between 16 and 36 will have the geometry series, the limited sum. Okay, so now I just do the limited sum. As the theta limited sum, so will be equal to theta a on 1 on r. Since the limited sum, that's the formula here. Then continue theta s, theta limited sum, so will be equal to a. A is the first term, is 1. Then 1 minus r. R is a common ratio, it's 5, the minus root square root p. P is 20. Then equal to theta 1. This will be the square root theta 20 minus theta 4. So write your answer with a rational denominator, okay? Then theta s, theta n, then will be equal to theta top, the bottom, same times the square root 20. The square root theta 20 is plus 4. Then the bottom, this one times the square root 20 plus 4 will be give you the 20. So minus 4 squared is 16. Then which equal to 4 plus the square root 20 is 2 root 5 on 4. Okay, so I found the series, the limiting sum is this one. And then the denominator is the rational number. Okay, this is the first question. Then we look at the second question, is extension 1 question. Solve the x. Okay, so this one is the x square root and the x power log the base 2 theta x. then equal to theta A times theta X theta squared. Then I can write in the this form. So these are both sides divided theta X theta squared, then equal to theta A. And this way you can get x base the x, so power to the minus. So I can put it at this form x, then theta log the theta 2 theta x, then minus the 2, then equal to theta A. Then on both sides put the log. So theta log the base the 2 theta x, theta log the theta 2 theta x. So minus theta 2, then equal to theta log the theta 2 theta A. Okay, the logarithm, the power I can move to front. The theta power I move to front. So the log the theta 2 theta x. So minus theta 2. Then this we log the theta 2 theta x. Then equal to theta log the theta 2. A I can put as the 2 theta power theta 3. Okay, now the this one times this one will be log the theta 2 theta x. So the this one the square minus the 2 times this will be 2 theta log the theta 2 theta x. Okay, since the logarithm power I can move to the front will be this side equal to 3. I move to the left hand side with minus 3 equal to theta 0. Then I can factorize. So theta log the theta 2 theta x minus theta 3. Then theta log the theta 2 theta x plus the 1, then equal to 0. Okay, I make the this bracket equal to 0. So the log the theta 2 theta x minus theta 3 is equal to 0. Then this means the log the theta 2 theta x, so equal to theta 3. Then theta 2 power theta 3 equal to x. So theta x will be equal to theta 2 power 3 is the A. Okay. Then I make the this bracket equal to 0. The log the theta 2 theta x, theta plus the theta 1 equal to 0. Then theta log the theta 2 theta x will be equal to theta minus 1. Then the theta x will be equal to the 2 power minus 1. So theta x equal to theta 2 power minus 1 is the half. Okay, since the x is larger than 0, so I got the x is larger than 0. So this question just see the power, the logarithm power I can move to the front. Then I can solve this x here. Okay, now we do the last question, extension 2 question here. Okay, if the Rn is the integration, this one. So first one, so need to show Rn equal to this one. Okay, I'll start. Then theta I theta n, then equal to 0 theta 1, and theta x. And this will be 1 minus theta x power theta n theta dx. Okay, so theta I n then equal to I using the integration by parts. So this one, okay, I'll make the theta u equal to theta 1 minus theta x power theta n. Then theta u dash will be equal to theta n and theta 1 minus theta x power reduced by 1. This is the x floor have the -1, so this is the u dash. Okay. This is the v will be equal to okay, so I am equal to theta u v minus theta v u dash dx. So theta I, theta n will be equal to the u is the 1 minus theta x power theta n. U, v is the x square on 2. So theta limit will be start at 0 and 1. Then minus theta v is a half the theta x square. V du is the minus theta n. Then the this is the 1 minus theta x. Theta n, theta minus 1, theta dx. Okay, then equal to, you sub the 1 here, theta 0. You sub the theta 0 here, theta 0. The this power be 0. Theta minus, the minus the plus. This n on 2 are just move outside. So far I got the theta x theta square 1 minus theta x. Okay, so now so theta I, theta n, then equal to theta n on theta 2. Okay, this one, I can make the theta x times the x. Okay, then theta I, theta n, so equal to okay, so equal to theta n on 2. Okay, this one's the x here. Okay, this x, I make the minus theta x. Then the front, I just put the minus theta positive. Then this one, I can make the theta 1 minus theta x. Then theta I, theta n, then will be equal to theta minus n on 2. So the theta x is still here. The this one, I can plus the 1 minus theta x, theta minus theta 1. Okay, so okay, so now so theta I, theta n, then equal to minus theta n on theta 2. Then the this one, x times the this times the this one. Okay, we'll give you theta x. Theta 1 minus theta x power theta n. Then theta minus the theta x times minus 1 times the this one will be minus theta x. Then theta 1 minus theta x power theta n minus 1 theta dx here. Okay, so theta I, theta n, then equal to theta time. So this will be minus theta n on theta 2. The this one, just I, theta n. Then the this one times the this one will be plus the theta n on theta 2. Then this one will be I theta n theta minus 1. Then I move the c to the left hand side. That means 1 plus theta n on theta 2. I theta n. Then will be equal to theta n on theta 2. Theta I theta n minus 1. Okay, so now theta I theta n. So will be equal to theta n on 2. Theta I theta n theta minus 1. Then divide this one. Divide theta 2. Theta 2 plus theta n. Okay, so which equal to n. And this is the 2 plus the theta n. And theta I theta n minus 1. Okay, the first one is to show. So I already show In equal to this one. Okay, so now I'll do this second part here. So show deduce theta I, the theta n will be equal to 1 theta 2 times theta c theta n plus theta 2 and the theta 2. Okay, so I already show In equal to this one. Okay, so theta I, theta n, then equal to theta n plus the theta 2, theta I, theta n minus this one. So means I can write the theta In will be equal to theta n, and then theta n plus theta 2. Then theta In minus 1. That means the this one times the theta, all theta n using the n minus 1 to replace. Then will be theta n theta minus 1. Theta n minus 1 to replace here will be theta n theta plus the theta 1. Then times the theta In minus 2. Next one, just theta n using the n minus 2 to replace. Then theta n theta minus theta 2. On the this one, n using the n minus 2 to replace just n. So the next one, so this will be the n minus theta 3. Then next one, theta n, I'm using the n minus 3 to replace. N theta minus theta 3 to replace here. And this n using the n minus 3 to replace with theta n theta minus 1. Then continue. If the theta n is the 2, so theta 2. If the n is 2, so theta 2, then this will be 4. And this will be I1. So I1 means the this time n using the 1 to replace will be theta 1 and theta 3 and theta I theta 0. Okay, so now theta I theta n so equal to, so this one the top will be theta n times the theta n theta minus theta 1 times theta n theta minus theta 2 and theta n theta minus theta 3. Then times theta 2 times theta 1 and the theta n plus the theta 2. Then theta n theta plus theta 1 and theta n, then theta n theta minus 1. Then this will be the n minus 2. Then this will be the 4 times theta 3. So I0 here, you can see I0 here is 0. So means integration 0 on 1 theta x. Do the integration just equal to half. Then this is the time the theta half. Okay, from the here. So theta I, theta 0, then equal to theta 0, theta 1, theta x. Then this one, 1 minus x. So the theta 1 minus theta x power theta 0 the dx. Then equal to this one, so x squared on theta 2. Then theta 0 and theta 1, so give you theta half. Okay, so now theta I 0. So I 0 are using the theta half to replace. Okay, so now theta I n equal to, you can see theta n cancel the theta n minus 1 cancel the theta, n minus 2 cancel. So there will be theta 2, so cancel the theta 2. Okay, so now theta, the previous one, so must be the theta 3 already cancelled. Okay, then will be equal to theta 1 on theta n theta plus theta 2. Okay, so now this one, so just will be equal to theta 1 on theta 2 times theta c, theta n plus theta 2, theta 2. Okay, so the question want to ask show, I already show I n will be equal to this one. The last bit here, last bit is the find the n for theta I n. Okay, theta. So find the n, so theta I, theta n must be less equal to 1 on the theta. Okay, I n equal to this one, but I n less than this one. Then this means this one, this part, so must be larger than 132. Okay, so n plus theta 2, theta n plus theta 1, so large equal to theta 132. Then this one, so n plus the theta 2, so must be large equal to theta 12. Okay, so theta n, so must be the large equal to theta 10. Theta 12 times theta 11 is 132, but this left-hand side has to be large equal to 132. Then I can get the theta n must be large equal to 10. You can also do the expand. You can also do the this way. You can do the theta n squared plus the theta 3 theta n plus theta 2. So large equal to theta 132. Then theta n squared plus the theta 3 theta n. So minus theta 130 will be large equal to theta 0. When you do the this one, you also can find the theta n large equal to 10. Okay, so now, so we finished the last question here. Okay, so now for this one, the second question says I n short has to be short. I n will be equal to this one, which I already shown. Last bit, find the n force, which the theta I n less equal to this one. I n is here. And then this I n less than this one. That means this one must be the large equal to 132. Then I can find this n large equal to 10. Okay, so we finish all these 3 questions. Yeah, so if you have any question, so want to discuss, you can make the comment under my video. Or if you have your own question want to ask, also can make the comment under my video. Okay, thank you for watching. Bye-bye.